All right. Having said that, what were the questions? All right. Was it 272829?
Yep.
Yes.
All right. So this is what we wrote last night.
Yeah.
This is a MIPS processor in Scheme.
It's going by really fast. Sometimes it actually is.
And here's like an example program in our language at the end. Right now, this would actually support loops and conditionals. Yeah, pretty solid.
Cool.
These students are saying it took them 30 hours to not finish it. It's cowards, right? Huh? No, it was too hard of an assignment.
Right,
Well, I mean, if Scheme supported Toast, then Maddie would have had it out like.
We did watch Toast last night to calm the group. Not even kidding. We had at least 2 people crying during class. And there was 2 other ones that were right on the edge. One person couldn't show up to class. Yeah, it was a rough crowd. And then it didn't help, so I solved the first part of the assignment relatively quickly at the beginning of class, and then we find out that was actually the hard part. so I had to adjust. And it's not that it was hard. It was that there was an aspect of a thinking process to it that maybe was a little bit out of grasp, and it wasn't a core component of the assignment. So I should have just done that part for them, and that would have given them a better platform for the purpose of the assignment. But I will say to this group, and well as other classes, what I told them. So, teachers sometimes give assignments that are too hard. It happens. But you need to give feedback. Ask a question on Slack. Say, I am clueless. I don't even know where to start. Whatever it is. I get it that you show up and say, I spent 30 hours in this and I got nowhere. I feel bad, but I can't fix it early in the process unless you let me know that this thing is just out of your league. Now, it might be out of your league because you're not ready for the class, but if it's out of your league as well as every other student in the class except maybe 1 or 2, chances are the assignment wasn't necessarily as well thought out as it needed to be. But if I don't find out about it until the due date, I can't do anything about it. So half the suffering is on the student, right?
Yeah, goes back to the whole communication.
Yeah. If something doesn't smell right about an assignment, say something, and I'll either push you in the right direction or I'll modify the assignment. Because sometimes, when I give the assignment, I have a pretty good idea what I'm giving you, but I haven't necessarily spent more than like 6 seconds thinking about it. So sometimes that might throw you into a meat grinder or something, and that's not the intent. Well, sometimes it's the intention, but as long as there's learning on the outside. All right. So, flatten. This one is our first one. Flatten returns a list of the symbols contained in SList in the order in which they occurred. Okay, so flatten is an SList. So returns a list of the symbols contained in SList in the order in which they occur when SList is printed. Flatten removes all the inner parentheses from the argument. Okay, gotcha. So we have to remind ourselves what an SList is. An SList is a list containing either a symbol or an SList. Right? It's a list of symbols and SLists. That's what that guy is. Okay, and so we actually could probably accomplish this with a map. Let's not do it with map, though. Map would be pretty... That was the death knell last night. It was like the hardest part of the assignment. We did it a map in like 3 lines. It really broke their spirit. It's like, are you kidding me? I know he seems big, but we can take him down if we work as a team.
I don't let you go right.
All right, so define flatten. This guy is a lambda that takes in an S list. And what we're doing is we are producing we're building a list, right? So we already kind of know that one pattern. And we'll go ahead and use a cond here because we really have 3 scenarios. We're out of stuff. That's going to be the empty list. We're going to have the car as a symbol. That's going to be a cons. And then we're going to have the car is a S list, which means we need to append the result of calling our flatten on the car and flatten on the cutter. Right? I think that's the function. So cond, first guy is null S list, and this guy will just boil down to the empty list, or you could even boil down to S list. Those are synonymous with each other, right? If it's null, S list, and empty list are the same thing. So whatever makes you happy. If symbol car of S list, then we will, let's kick it down. We'll cons car of S list onto whatever's returned by flatten cutter S list. Else, the car must be a S list, so we will append flatten on the car S list and onto flatten on the cutter of S list. Like that. Here, I'll kick this down the line. Okay. So let's test it on some of the simple ones here. So this guy should actually not do anything. Well, he should just give us the original list. There's nothing to flatten in a flat list. This guy's a little bit more interesting. This should give us the list ABC. A, B, C, D, E. And ABC. All right, so that's that one. And that was the hard one or the easy one?
I'd say that one took the longest.
This one took the longest. So did what I just did break your spirit a little bit?
A little bit.
I did mention in class that I have a scheme interpreter in my brain. It was installed at birth. It was actually a Lisp. It's a Lisp interpreter. I had it upgrade when I was 6. That's the scheme. Back then, they didn't have some of the cool technology we had today. They went in through the eyes with one of those.
Small incision.
No, it was not a small incision. They used.
They actually used the butter.
Imagine one of the manual wine bottle openers. All right, so questions on flatten. The real trick on this one is the append in this last part. That's probably the this is that part should be trivial, right? We were definitely building a list. Out of stuff, finish our list building. This part should be relatively trivial. S lists contain symbols and S lists, so you should have been pretty good on those two lines right there. A common thing I would have seen you making is, so the else, you should have known the else is an S list. Cool with that. But many of you probably tried a cons here, and then you got results that had lists in them. And then maybe that was a mentality that you had to kind of work through to kind of stumble upon that append will glue two lists together, taking away the list components, right? Yeah, so this is probably, I don't know, call it 95% of the complexity of the question is the append. Okay.
I think the complex one is when you go button 2 times. That's what I was just kind of stuck with.
Well, right, but this is a pattern we've seen. We know if we're in this else that this guy is an S list and that this guy is an S list. And what do we do with S lists? We call flatten on them. So, I mean, that's an important thing. So listen to what I'm actually saying. If we're out of stuff, we're out of stuff. We're done. If the car of it's a symbol, I don't need to process it anymore. I'm just going to keep it, and the rest of it I know is an S list. What do we do to S lists? We call flatten on them. That's what flatten operates on. Flatten operates on S lists. If I'm in this else, that means the car actually is an S list, right? So forget about the append part. We'll call that's the magic piece of this. So that means I know the car is an S list. This guy's an S list. What do I do to S lists? I call flatten on them, because flatten works on S lists. I know the cooter is the rest of my S list. So it's an S list. What do I do with S lists? I call flatten on them. So you see, when you kind of talk through it like that, it kind of tells you what to write. Does that make sense? Yeah. This would have been the trick part, the append. So I could totally see, so just to kind of maybe tell you where you should be in this class at this point, you should have been able to get, I would say, up to here very quickly. 10 minutes or less, something like that, depending on, confidence with scheme. This you may not have ever gotten, or it, this was the last thing that came together for you. But knowing to call flatten and flatten, that maybe would have been the next, call it 10 minutes, 15 minutes. I'm thinking maybe this is like a 30-minute question. All right, give me some context. Not 30, what was it? 30 hours.
Like a 10-minute question.
Okay, so he's obviously catching on to scheme very quickly. So yeah. for the class, and I want to hear from Jack. So I'm guessing it was 10 minutes or less or something. But what for like the global group? What was just give me a water temperature reading for this. What did this take you to do? 40 minutes, 3 hours. I mean, none of your answers are like embarrassment. It's going to be beneficial to me, so I can kind of gauge what to give you for assignments.
About an hour for me.
Hour-ish. Hour?
You looking at me?
Yeah. Well, you said you struggled with this one. You said this one took you the longest.
I'll slack you.
Well, you don't want to say it out loud?
No, I mean, like, it took me...
Because you know it's going to pop up in my notifications.
Don't tell me that.
By longest, I mean it took me 4 minutes.
Yeah, it took me like 40 minutes just to get the append part. I mean, it took me longer.
Okay. So will we call this an hour-ish question? That feel like let's call it where you maybe should be in the class?
About, yeah.
Well, that's not even like a knock on you. You tend to analyze over things longer than the average student. So 3 hours for you might be about a 1 hour for somebody else, because you sit there and stew on things. That's just your natural cadence, right? That's what you tend to do, and that's fine. Okay, so this is 1 hour. So that what does that make the other ones? Like just the infinity sign? So we got to do the math. So I solved this verbally in about 4 seconds. So oh man, now we're back to that old, how much did 8 megabytes of RAM cost me in 1996 compared to what it would cost today? I paid $1,000 for something it would cost like 0.003 cents today or something like that. All right, well, let's see. Maybe the other ones will be more difficult. All right, next one is called merge, right? If we have time, we'll come back and we'll do a. Well, actually, we're not going to be able to do. Well, we can do a map on flatten, but it doesn't make like life easy or something because you might have lists inside of lists inside of lists. It doesn't really do much. All right, merge. So we have LOIs, the list of integers, and they are sorted in ascending order. Oh yeah, this is our merge sort, right? So remember merge sort? Merge sort has, we have an array, a list, a collection, and ultimately, after we make all our recursive calls, we are left with 2 partially sorted lists, right? So this merge thing here, this is the process of going through 2 lists and building a single list that's in order by looking at the first element of each list, deciding which one is smaller, keeping that one, then calling merge again on what's left, right? So, define merge to be a lambda that takes a list of integers 1 and a list of integers 2. So 2 lists of integers, and they gave us the information that both of these lists are already sorted in and of themselves, right? So we need to ask some questions. We want to know if there is a car for both of those, right? If there's a car for both of those, then I need to compare them. If one of them is empty, I want to keep the other one. Mm-hmm. If the other one is empty, I want to keep the other one. So we could say cond null LOI1. If that guy is empty, what am I going to do? I'm going to return the other guy. Go ahead.
Okay, I had a question about that, because that's originally what I did, but then when I looked at the problem, it said that it wants them to be sorted as well. So
they already are sorted. LOI1 is sorted in and of itself. So an example of this would be like 1, 2, 7.
Yeah.
An example of this would be 3, 14, 15.
Yeah.
So they're already sorted themselves. If I'm out of things to look at in here, I know that the rest of this guy will be the next elements in my list.
So we're assuming that the lists are both already sorted.
There's 2 ones in each.
Our list of integers that are sorted in ascending order.
Okay. I did more work than I needed.
Yeah, but understand, this is the merge step of the merge sort, right?
So basically, I was doing both of them at the same time.
Yeah, the merge step of the merge sort. So we just split merge sort into 2 questions.
Okay.
Yep. All right, so if the first guy's empty, return the other guy. If the second guy, I hit a button. What button did I hit? Ninja'd.
There you go.
If the second guy is empty, return the first guy, right? Else, I need to ask a question. If I'm in this else, that means that both of my lists have elements in them. So I want to find out which one is smaller. So else, if less than, car LOI1, car LOI2. If the car of LOI1 is smaller than LOI2, what am I going to do? I am going to cons the car of LOI1 onto merge, passing it the cdr of LOI1 and LOI2. Otherwise, I'm going to cons the car of LOI2 onto the merge of the merge of the LOI1 and the cooter of LOI2. Like that. Ninja. So 11248.
I found that their second example was a harder test than the first one.
Am I going to pass it?
Probably.
Well, now you got me all nervous and stuff. My left eye has not been working great today. So I can only see half my screen at once. That's why I keep turning my head. That's right, isn't it?
Yeah.
All right. So that works. We've checked it for everything. All right. So questions on that one? So now let me try to do the math on this one. The first one was a 1 hour question. This was 2 hour question?
Took you less?
Yeah, it's actually, I thought it would take me longer, but this question took me less than the first one.
So is this another like 1 hour question?
This one confused me a lot, but I confused myself.
Oh, yeah, you didn't read the question.
I questioned
Yeah, you're disqualified. You didn't actually read the question.
I basically have that, and then I was like, wait, that's not right. But it was.
Yeah, so the struggle you may have done on this one is trying to deal with do I have cars for both lists or only cars for one of the lists? Or do I have cars for none of the lists? So maybe some of you would have had something like and null LOL1 and null LOL2, something like that. You know, you would have asked about both lists being empty, and then if you passed that test, then you knew that at least one of them wasn't empty. Then you could ask the question of if null LOI1, do LOI2 stuff. Otherwise, if null LOI2, do LOI1 stuff. Otherwise, they both have cars, do the comparison stuff. Yeah.
So I just want to point something out that was kind of interesting with how you did this.
Mm-hmm. Interesting good or interesting bad?
Interesting good.
Okay.
Like hidden important.
Oh,
kind of.
good.
So like the base case, the thing that like it stops at is when both of them are null, right?
Correct.
And in that case, we want to return an empty list, and it works out. Fine.
Yeah. So I'm missing that pattern, is what you're saying.
Well, but it's still there. Like just
well, sort of.
Subliminally.
We don't know that that's empty. We know that's a list.
Yeah.
And more importantly, we know that is not a recursive call. That is a stop case.
Yes.
Yeah.
Yeah.
Yeah. So that is a good point that we don't. Oh, go
But
ahead.
in the case of them both being empty, or the first one being, they're both empty, it sees the first one as empty and gives out the second one. And if it is empty, it's just an empty list, which is what we want.
Right.
Correct.
Moving cons onto the empty list. No skin off our back.
Right.
So,
Yeah. So this is a little bit different. This is like a weaker version of the pattern we've seen before, where we're not necessarily finishing a series of conses with a guaranteed empty list. We are just finishing a series of conses with a guaranteed list that may or may not be empty, but it's a list. For all we know, all of our smallest numbers were in the first list. And when we run out of this guy, we might still have 400 elements in this list, for all we know. We might not have had one winner from LOI2 at this point. And we just got this giant list, and we're just returning it, saying, here are the rest of your numbers. And they're already sorted because we read the question.
So I used an example that wasn't the sorted list. Like I was trying my own case, and I'm like, wait, that doesn't work.
no.
That's pretty funny.
So what did you do for sort then?
Well, Then the sort
I got
was like-
stuck in an infinite loop and couldn't sleep.
Well, I mean, it's been a sort function on its own, but then when I tried to use it like with merge, I was like, this isn't working. Things got a little convoluted.
All right, sort returns a list of the elements of LOI in ascending order. Okay, so this one actually gets a little bit more interesting, right? I think I tell you in class you're not allowed to use like a built-in.
Which
I
you
had to
did say
rename
that,
it, yeah.
and specifically sort is the name of the built-in
Yeah, which-
function,
which is
so
kinda
we
weird.
will need to rename our function.
Mm.
Just kind of dumb.
So let's think through this. We have this list that's all jumbled up. We know that this guy's going to work in conjunction with merge, right? Hence the reason they gave you the question for merge first. So ultimately, what I want to do is I want to get this guy into two sublists, right? And then call merge on those two sublists. I already have a tool that we just wrote for sorting as long as I have sublists. So I'm going to be building up, so I'll probably need a helper for this guy, right? I'm going to be building up two sublists. Well, I could do it as a let rec or, well, once we get into it, we'll see what I bump into. But we're going to be building up two sublists in preparation of sending things to merge, correct? All right. Now we can approach this with our traditional merge sort approach because that would be the fun, cool kid way of doing this, right? Well, how does merge sort work on this? Merge sort says, is this guy the one list? He's not. There's a bunch of stuff in there. The length of that guy is greater than 1. So what do? We split it in half, right? How do we split it in half? Well, I have to figure out where the halfway point is, and then I go from the beginning to that halfway point, and I go from the end to that halfway point. So I need some helper function that will do the split for me. Okay, did we try to do it as a merge sort, or did we try to do some convoluted thing?
Well, at first I wanted to do it as like a bubble sort or something.
Okay.
But I was like, screw it up.
So let's do this mechanically as merge sort since that kind of haunts our dreams, right? All right, so. All right, so you're saying we need to call this guy like Msort?
Yeah,
like that?
I called it sort too.
All right, so this guy is going to be a lambda that's going to take in a list. This one would be an unsorted list, or at least not guaranteed to. That is not guaranteed to be sorted for this guy. All right, so we are going to ask a question. So we're going to say if I'm going to do this as a cond. I think that'll because we can. Yeah, whatever. So, null list. If I'm out of stuff, I can just return the empty list because I'm building up a list, presumably, right? All right. So, that's if I don't have anything to look at. If I'm here, I do have something to look at. That means the car of list is a thing. What do I do with the car? Well, if I do have something to look at, I need to know whether the length of that guy is 1. If the length of it is 1, it is a sorted list already, trivially sorted. So I only want to take an action if its length is greater than 1. So cond greater than length, let's see, length LST1. If the length of LST is greater than 1, that's true, then what do? I need to make 2 calls to merge sort. That make sense? Now, what do I do with those 2 calls to merge sort? Remember, I ultimately want to end up with 2 sorted lists. Good.
Would you merge a sort of your first half and a sort of your second half?
So we're ultimately going to be doing a merge. And if you remember from merge sort, we do a merge step each time through. Okay, he's right. So what are we going to do? We're going to call our merge function that we already wrote on whatever Msort returns for the first half and whatever Msort returns for the second half. Well, now we need to figure out, how do I get the halves? How do I get to the first half of this list and the second half of this list? Because that's really the only problem with this question. We're almost done.
Does it have to be exactly in half?
It has to be consistent.
Or can we do car and cooter?
Yeah.
Car and cooter would be horrifically inefficient, but it would work. Now, we would have to make the list of the car.
Right.
And then the cooter. Maybe let's do this in the spirit of merge sort. Because really, merge sort will work on two lists, but merge sort is most efficient when we're dividing our data roughly in half. As long as we're always dividing it in half, the same way, that the larger half is always either the left or right when we have an uneven number of elements. You can't flip coins and make it sometimes one or the other, because then you'll start losing values. You could cheat. Hey, it's the computer. We're telling it what to do. Who cares?
I mean, with using car and cooter, wouldn't it build up in the same way though? Because before it can run the first merge function, it's gonna have to cooter all the way down to the empty list, right? So
Yeah, but you're gonna run merge tons of times in just one list. So what he's gonna do is he's gonna have a list of 500 elements, and what he's gonna do is he's gonna call Msort on a one element and an Msort on a 499 list.
So it's basically insertions.
Okay.
Yeah. He's not load balancing his two lists and say sort this guy and sort this guy. Because the idea of merge sort, where merge sort really shines, is either in multiprocessor or message passing network distributed operating systems, where we can say, hey, I'm going to give this computer the left half of this list. I'm going to give this other computer, this other processor, whatever, the right half of this list. So have these guys independently and simultaneously working on sorting the data. And if you have enough cores, you can actually sort large amounts of data somewhat instantaneously, because you keep passing the buck, having unused resources work on smaller portions of the list. That makes sense? So we need to get the first and the second half of this guy. So we're going to give ourselves, I'm just going to close this for a second. We'll come back to it. So we want to call our, so we'll say define SliceDice. That's going right. And this guy will be a lambda that takes a list. And what he's going to do is he's going to return a list of lists, where the first list is the first half of LST, and the second list is the other half of LST. At least that's what's in my head right now. So I'm going to return a list containing two lists, where the first thing I'm going to pass to merge is going to be the car of that guy, and the other thing I'm going to pass to merge is the catter of that guy, the second element. All right. So I'm going to take a list. That list has a length. We need to roughly get the midpoint of this. Has the book introduced LETs yet? What do we have access to?
No LETs.
No LETs. Okay. So we know that the, and let's see, let me test something here real quick. Okay, so we need to, what was that? Quotient, right? Quotient is our 5, 2 to give us the 2. Okay. Yeah, you could have used it with floor, I guess. All right. So slice and dice. What we're going to do is we're going to get the midpoint. The midpoint is going to be the quotient of length list 2. So that gives us the midpoint-ish way better than just take the first guy. Right? It's like the midpoint is after bucket 1. that's your midpoint. So just take the car, easy peasy. Alright, so we'll take the quotient of the length of a list divided by 2. This will give us that midpoint. So now we want to get the portion of our list up to, and we can either decide up to and including that, or up to but not including that. We just have to always make that assertion, right? So I'm going to say define, maybe call this guy SplitList. This guy's going to be a lambda that takes in a list and a pause. Well, let's maybe call this split pause, the position that we're splitting it. Okay, and what he's going to do, and actually I'm going to do it this way. We're going to call this guy list 0, list 1. So I'll pass in the original list and I'll pass in an empty list, and we'll start building up that empty list. Yeah, this will be fine. So split pause, we're going to count down. So we'll ask the question, if equal split pause 0, then I'm going to return a list containing list 0, list 1. I've built my 2 lists. That's what I'll boil down to. All right. Otherwise, if it's not 0, what am I going to do? I'm going to call SplitList, passing it my original list 0. I think the way I'm going to pass this in is I think I'll pass the empty list and then my full list. I'll just start filling that first one with the first split pause number of elements. So I'm going to cons the car of list 1 onto the current version of list 0. Right, so I'm building up list 0. That'll be the first parameter I pass into back into SplitList. Then I'll pass the cdr of list 1, everything but the first element. And then I'll pass the minus split pause 1. That makes sense? So when I call this guy, he's going to be called SplitList. So I can come down here. Where did I slice and dice? Right here. So we'll ask the question here. Actually, we're not asking the question. That's going to be my pause. So we're going to call SplitList on the empty list along with list along with my split pause. Like that. So for example, if I were to call slice and dice, passing it the list 1, 3, 2, 7, 4, something like that. What I ultimately want him to produce for me, so this guy has a length of 5, so I ultimately want him to produce for me a list containing 1, 3, and a list containing 2, 7, 4. That's what he'll give me. And how are we accomplishing that? Well, we're calling SplitList, passing this guy initially the empty list and my entire list, that 1, 3, 2, 7, 4, and my split pause, which in this case is 2. Okay, so I'm calling SplitList, passing it an initial empty list, a list, which is my 1, 3, 2, 7, 4, and then the quotient of this guy, which in this example would be a 2. 5 divided by 2 is 2. So what does SplitList do? It says, is split pos equal to 0? Is 2 equal to 0? It's not. So what do? I go to the else. I'm going to call SplitList on the cons of my car of LST. So I'm going to take that 1 here, and I'm going to start consing that onto whatever list 0 currently is, which is the empty list. Then I'm going to pass it the coulter of list 1, which is the 3274. And then I'll subtract 1 from the 2. So now the 2 is now a 1. Next is split pos equal to, and then I recursively made a call it. Split pos equal to 0. Is 1 equal to 0? It's not. So I will cons the 3 onto whatever list 0 currently is. So actually, this is going to give me my list in reverse, the way I'm building it right now. Because I already have I've cons the 1 onto list 0, and no, we're fine. It'll build in the right order. So I'm consing the 3 onto whatever list 0 currently is. Oh, no, list 0 is currently the list 1. Yeah, so this will build it in reverse, and that's fine. We could do an append. We could do an append on this
I can have a question.
guy and the list of this guy if we wanted to. Go ahead.
If you put list 0 in front and then car list 1 behind.
The second element of a cons always has to be a list.
Oh yeah.
So if you wanted to do that, if you wanted to build this in order, what you would actually say is append this guy and the list of that guy.
So then if you're using con, then you have list 0 and then you just have list car, whatever, would that do anything?
Well, list 0 is a list, so you would be adding that list as an entire element onto the front of that guy.
Oh.
You get a very heavily
Yeah.
listed list.
So this will build it in reverse. Or if I go back to this, sorry, one more. I go back to this. What I can do is I can just call reverse on list 0 here, because I've built it in reverse and there is a function called reverse. Or we can write our own reverse if we want to. Okay, it wouldn't be the end of the world. Okay, so once we count down, so we have the 1, we have the 3. Once we count down to 0, what do we do when we finally hit a 0? We create a list out of the reverse of list 0. So we reverse 3, 1 into 1, 3. Then we get the rest of lists. Well, we get list 1, which we've been passing in as the coulter all along, right? So that should already be the list 274. So we are going to boil down to that a list of 2 lists. Well, a list containing 2 lists. So then what does slice and dice do? It's going to boil down to that list of 2 lists. And what will we do in here? We're going to call merge on slice and dice of LST. So that's going to give us that list of 2 lists. This would be a pretty nice place to use a let, but since we don't have that at this point, we're going to go ahead and say I want the car of this guy. And I want the catter of that guy again. So do the math for me again. So I'm actually slicing and dicing my list twice. At twice the effort. All right. So that should be, I'll have to put the M on that guy. my little comments here telling you what I was doing. It's LST1, isn't it?
Yeah.
Blaine,
Sorry. You're doing a lot there.
I gave you one job.
Oh, wait.
That doesn't look in the right order. Did I call merge on?
Is it because we're calling catter and not cutter?
I'm taking the car of the cooter.
Yeah.
That should be right. Here, let's just see if it gives me the right two lists.
It didn't actually sort them, it just stuck the back end on the front end. Or no, the other way around.
Oh yeah, you never called sort again.
Oh, thank you.
I was wondering too, what it is.
So we're calling, if the length is greater than 1, we're going to do a merge on those two guys, and then we're going to call Msort on the result of that merge. Why is it still giving me a two list? Here's my merge.
Oh.
So we saw that. Well, hold on. I want to see, does that give me the right starting point? I have an extra parenthesis in there right now. And we're out of time anyways, but
So would you merge the sorted version of the car and the catter of SliceDice?
yeah. We're calling Msort on the first half and call Msort on the second half. That's what merge sort is. Call Msort on the first half, call Msort on the second half, where the second half is, where the two halves are the left half and the right half. This will do it. All question results were false.
Oh, we don't have a base case.
Well, we don't need a base case. We'll just never have a null list.
You need else at the end, since it's a con.
Well, we don't actually need to ask if it's null. I mean, else at the end would give us a final case. So we can say else like this and just say it's the one list, so it's already like that, but we're never going to actually hit this.
Yeah, I was thinking the merge was a part of your else statement.
Yeah. So this does it, but this is actually a wasted statement right here, so we probably should have done this as an if. Because we're never actually going to be null. Well, the worst that we get to is a one list, and what do we do with the one list? We just boil down to that list. All right, so this is your traditional merge sort. We just happen to have to slice and dice twice because we don't know about lets yet. So I'll show you lets on Monday. I'll paste this code up. Let me give you a question for over the weekend. So I'll give you this code as a starting point. Let's just do 1.3. So you have a starting point for our merge sort done the merge sort way. Okay? And so make sure you understand that and then take that as your starting point, and now you're sorting based on a predicate instead of necessarily less than. Okay? So 1.3 is the homework in terms of an actual merge sort version of merge sort. Got it?
Next class, would we be able to look at a sort algorithm that wouldn't have used the merge that we just wrote?
Yeah.
Okay. I was kind of curious how you would.
Yeah, so you want to do like a bubble sort or insertion sort or something like that, and just pretend merge doesn't exist.
Right, kind of keep these two problems separate.
Yep, we could do that.
Oh, I would. Yeah.
If you have CADR, that means coder first and then car.
CADR, you're going to take the car of the coder. So you'll take the coder first, then take the car of that.
So that's the second one.
Coder first.
I didn't get it. It just wasn't allowing when I was trying.
Hang on, but then why would we need that coder first for the car?
Because we had a list containing two lists. The car of that is a list. The coder of that is a list containing a list. I need the car of that coder to get me just the list.
Because I feel like if you split it in two lists, right? And then the car of us is the first half. So then the coder of us would be the second half though.
Yeah,
So
here.
then why would I need to have the
Let me just show it to you. I'll just write it here. So if I have the list 1, 2,
yeah.
and I have the list 3, 4, like that, the car of that guy is the list 1, 2. So if this guy is define LST to be this guy,
Oh,
the car of LST will produce for me 1, 2.
okay.
The coder of LST will produce for me the list containing the list 3, 4. The catter of LST will produce for me the list 3, 4.
Oh,
Or I could say the car of the coder of LST will give me the list 3, 4. Okay, because the coder is a list containing that list.
all because the coder is the list.
Coder is
Right.
always a list. It just happens to be
A list
that this
containing
is a list
Okay.
that has lists in it.
So then car returns an element while coder returns a list. So that's why it's
Yeah. Well, coder always returns a list. It just happens to be that this list here, its elements are lists. So this does return, the coder here returns a
makes sense.
list of the rest of the elements.
so basically we want to take an element and not the list. Of
Correct.
Okay.
Well, we want this guy. This is our second half of our
For
list.
that homework specific, I did split the thing into half. It's not whatever you just wrote up there. It's just like two different functions for head and tail.
Mm-hmm.
And then after that, I'm like, can't function.
Let's see, CSC470. This is fall 2019.
Is it like our class is like that smart that everyone just finished it in 30 minutes?
Well,